Chapter 14, Section 3 in the 8th grade workbook is entitled Adding Polynomials. This is the homework helper for Chapter 14, Section 3. So remember, when we're adding polynomials, what we want to go ahead and do is identify like terms. Remember, they're like terms as they have the same variable to the same power, or perhaps no variables at all, in which case they'd just be integers, and we'll go ahead and put those together. So number one, we've got a squared plus a plus 3 being added to the second polynomial, 15a squared plus 2a plus 9. So let's go ahead and match some things up here. We've got a squared is going to match up with 15a squared. Reasoning is because they both have a squared in them. So since they both have a squared in them, just a squared, we can go ahead and add those together. If I give you an a squared, and then I give you 15 more a squareds, then of course we end up with 16 a squareds. Alright, then we've got this a term here. It's going to match up with anything else that just has an a in it. And as you can see over here, we have 2a. So I'm going to be able to go ahead and combine a and 2a because they both have just a in them. They are like terms. A and 2a, or if I give you an a and then 2 more a's, how many a's do you have? Either way, that's going to go together to make 3a. And then, of course, you've got these integers here, which we know we're going to add together using the rules of adding that you've been using forever. 3 plus 9 changes into 12. So that whole thing, a squared plus a plus 3 plus polynomial 15a squared plus 2a plus 9, simplifies to 16a squared plus 3a plus 12. As you heard me say in the notes today, a lot of the times we do write these in standard form or descending order with the biggest exponents first and the smallest or no exponents last. And as you can see, that's exactly what we did here. The directions do not imply anywhere that you have to do that, but a lot of the times we'll end up doing that anyway. All right, let's go ahead and take a look at the question under that, number 3. mn minus 10 plus mn squared being added to the second polynomial 5 plus 3mn minus 4mn squared. So let's look at this first term here. This first term says just mn. So we're looking for anything else that has mn in it. Well, here's mn over here, 3mn. So I've got an mn, and then I'm going to add 3 more mn's, and that's going to go together to make 4 mn's. So that's 4 mn. Now here's 10. Of course, that's just an integer, so that's going to go with anything else that's just an integer. That's this guy here, this 5. So we've got negative 10 plus 5, so we can write plus negative 5, or we can write minus 5. The end result is the same, doesn't matter. And then we've got this mn squared here. That's going to match up with anything else that has mn squared in it. And of course, this does have mn squared in it. Again, we're combining like terms. Like terms have those same variable parts. They both have mn squared, so we can put them together. Well, let's do what this says. If I start you off with an mn squared, remember if there's no number there, it's like a 1. If I start you off with an mn squared and then I take away 4 of those mn squareds, you have negative 3mn squared left. So you can write minus 3mn squared or plus negative 3mn squared. Either way, the result is the same. So mn minus 10 plus mn squared plus second polynomial 5 plus 3mn minus 4mn squared simplifies to 4mn minus 5 minus 3mn squared. And again, those can be in any order. If you wrote the negative 3mn squared first, that's fine. It does not dictate here in the directions how they have to be written in standard form or descending order, not. It doesn't say anything about that. So whichever order you write it in, as long as you have these parts with the correct signs, you're going to be okay. Now, as you can see, as we head down here to the 5 through 9 part, now they've got multiple polynomials, not just 2. They have 3. Here's another one with 3. Here's one with 3. And then 8 and 9, all of a sudden, you get down to having 4 polynomials. But it's still the same thing. It's all about combining the like terms. So let's look at number 5. S cubed plus 3s minus 3 being added to 2s cubed plus 9s minus 2 being added to s minus s cubed. All right, so let's start with the s cubed things. These all are just s cubed. There's nothing else with them. There's in terms of variables. There's no t's, there's no x's, there's no j's, there's no a's. They just are s cubed terms. So let's combine. We've got s cubed, and then out here it's going to say minus s cubed. Well, of course, those are going to cancel each other out just like 2 minus 2 would. So that's gone. And then we've got this 2s cubed here. So when we add all that up, that's 2s cubed. All right, let's grab the things that are just s now. Here we've got 3s, here we've got 9s, and here we've got s. So 3s plus 9 more s's is going to change into 12 s's, plus another s out here is going to change into 13 s's. And now we've taken care of all those. And then the only thing we have left to deal with are my integers. So that means I've got to take care of the 3 here. And notice that's got a negative or a minus in front of it, depending on how you read it. And here's a 2 that's an integer. And again, same thing. It's got a minus or a negative in front of it, depending on how you read it. So either way, when we add those together, that's going to give me either minus 5 or plus negative 5. So I'm going to tack that on to the end of the answer. So s cubed plus 3s minus 3 plus second polynomial 2s cubed plus 9s minus 2 plus third polynomial s minus s cubed simplifies down to 2s cubed plus 13s minus 5. All right, let's look at number 6, a long one. 6wv minus 4w squared v plus 7wv squared plus 5w squared v minus 7wv squared in the second polynomial plus wv squared minus 5wv plus 6w squared v in the third polynomial. So as you can see, we've got a lot of squares and single powers, but they're kind of flipping around here. So we want to make sure we still continue to gather the like terms here. So here's something with wv in it. So it's going to match it with anything else that's just got wv in it. No exponents, just regular old wv. Well, there's nothing else in this one. There's nothing at all in this one. And this third one, the middle term, has just wv in it. So I've got 6 wv's minus 5 wv's. That's going to go together to make for me 1 wv. Notice this has got a minus in front of it, as I said. You can treat it like it's negative if you want, but either way, when you have 6 and you take away 5, the result is 1, no matter if I say subtract or treat it like it's negative. All right, let's get the w squared v terms next. So we're going to match it up with anything else that says w squared v. Well, here's w squared v in polynomial 2. Here's w squared v in polynomial 3. Let's go ahead and combine. So I've got minus 4w squared v plus 5w squared v. So that's going to change into 1w squared v. And then out here at the end, I got 6 more w squared v's. So that's going to change into 7w squared v's. And then we'll get what we have left, because everything that's left happens to be a set of like terms. They're all wv squareds, as you can see. They all say wv squareds. So I've got 7 wv squareds minus 7 wv squared. So that wiped them out. And then I'm going to add back in a wv squared. So I have 1 wv squared. So that long mess changes into just 1 wv plus 7w squared v plus 1 wv squared. All right, let's look at number 7, one more question. 6b squared c squared minus 4b squared c plus 3bc being added to polynomial 2. 9b squared c squared minus 4bc plus 12 being added to polynomial 3. 2b squared c minus 3bc minus 8. All right, so first thing we see here is this b squared c squared term, so we're going to match it up with anything else that's b squared c squared. Well, the only other one that I see that says b squared c squared is the first term in polynomial 2, as in 9b squared c squared. So we'll go ahead and combine those. 6b squared c squared plus 9b squared c squared changes into 15b squared c squareds. All right, now the next thing we see here says minus 4b squared c. But if you take a look at these other two polynomials, there's nothing in those that says b squared c. So he's going to hang out by himself. So it says minus 4b squared c. So I'm going to write in my answer minus 4b squared c. Now this next thing says bc. Well, we do see that's going to have some matches here. Here we've got in the middle of polynomial 2 a minus 4bc, and in the middle of polynomial 3, you've got a minus 3bc. So we're going to take care of those. Well, the 3bc minus the 3bc is going to wipe those out, so that's going to be gone. And then I'm going to take away 4 more bc's, so I'll either be at negative 4bc, or we can write plus and negative 4bc, or minus, whichever way you want to do it. Minus or plus and negative, it's the same thing. So we're going to write minus 4bc's. And then as you can see, we've just got these integer terms left to combine, 12 minus 8 like it says, which I'm going to write minus 4. So that 3 polynomials there simplifies down to 15b squared c squared minus 4b squared c minus 4bc minus 4. Keep on identifying like terms there, put the like terms together. That's all this section is really about.